Okay guys, so today's, like I said, is a little more involved. These are a little more in-depth problems, but sometimes there's things that are actually easier about them. They give you some context clues. This very first one is going to be one of those. This is talking about a proof. It says if they completed the proof, what's this missing thing down here at the bottom? So starting off with, it says angle 1 is congruent to angle 2. Mark angle 1 congruent to angle 2. Number 2 says that RA is congruent to RA by reflect. This whole line down the middle is congruent to itself by reflexive property. Step number 3 says that angle 3 is congruent to angle 4 by the given information. So that means, guys, do y'all see the two triangles that would be congruent to each other? Okay, we're trying to prove right here that these two triangles are congruent. So what would go here in this block? What's proved congruent based on angle, side angle? Do you need to try to go up here and name it, match it, and do all that? Got to use angle 1 in it. It's got to go all the way to the other side. So it's going to have to be... And then RL, I'll do it in blue. Guys, did you see they actually already gave you the answer to this? You see where it says prove? They actually already gave it to you. That's the triangle you're trying to prove congruent. The answer's right there. Sometimes it's easier than I think. They gave it to you. You just had to make sure that you saw that. So that's going to be A. Sometimes there are context clues, guys. Okay, number 2 is y'all's. I'm going to leave that to y'all. We're going to go down to number 3. I am going to make it bigger, though, so we can see it. So for number 3, I just had it that way because you couldn't see this whole problem together. So let's go down here to number 3. Told you they're going to find ways to do this. You'll see when I get there. You're starting off at a point. And this person, Miranda, rode her bicycle 4 miles south. So go down a certain amount, put another point, label it with a 4. And then 2 miles east. 1, 2. 2 miles east. And then 5 miles south. Y'all know east is represented by going to the right, right? That's when you go east, you go right. And then down 5. And then we're going to the east 10 miles. So that's a longer piece. That's 10. It wants to know the distance from where she started to where she ended. So what we're looking for is actually, ooh, not that. Try to draw this connection. Nope. I try to turn my paper and it doesn't help. Isabel, is it uncomfortable? Yeah, I'm sorry, sweetie. I know it's not fun. Okay, guys, what shape do we have?
Triangle.
What kind of triangle? Right triangle. Let's show you by doing this. If I draw this line here, how long is that line that's red? 5. And if I draw this line right here, how long is that line? 2. That means this side altogether is how long? 9. And this side altogether would be 12. And we don't know this side, and when we know 2 sides of a right triangle and we want to find the third, we use Pythagorean theorem. Thank you. Pythagorean theorem, which is going to be 9 squared plus 12 squared equals x squared, which would be 81 plus 144 equals x squared. What's 81 plus 144? 225. Oh, that's a perfect square. That's easy. Take the square root. Take the square root. What's the square root of 225? 50 equals x, which is choice A. Guys, y'all see that they throw that, they're going to throw Pythagorean theorem in weird ways into this question. Like, that question didn't look like it was going to be about a triangle to start with, but it is. Okay, here we go. Next one, number 4. The diagonal of a square is 13 centimeters. So draw a square. Draw the diagonal. That diagonal is 13 centimeters. Each side is the same. It's a square. Because it's a square, we also know that all the corners are right angles. And because these are right angles and I cut them in half, what's on either side of that? Half a right angle. 45. What kind of triangle did I just make? A 45, 45, 90. And to go from the hypotenuse to the leg of a 45, 45, 90, you are going to divide by what magic number? Yeah, radical, however you want to say it, root 2, radical 2, whatever, it's square root of 2, they're all the same. Okay. To do that, you're going to have to rationalize, you're going to have to get that radical off the bottom, so it's going to be 13 divided by square root of 2. Get rid of the square root of 2 on bottom by multiplying top and bottom by square root of 2. It's going to be 13 square roots of 2 over, guys, what is the square root of 2 times the square root of 2? 2. Because the square root of 4, but the square root of 4 is 2. Okay, here's the problem. What answer is that? It's not the answer to the question. Remember I told you that on every problem, once you do the work, the last thing you ought to do is reread the question. Reread the question. Is it asking for the side? Nope, it's asking for what? Which means we have to multiply by what? 4. It's not the side, but look what's there. You see the answers there, that what you got? You're thinking, oh, I got the answer. But it's not the answer. They put those on there on purpose because they know what the steps are to get to the answer to the problem. Please reread the question before you answer the question every time. So we're going to multiply this by 4 over 1. Why 4 over 1? Because it's multiplying by a fraction, so I want to make it multiply by a fraction. I'm going to cross cancel. 2 goes into 2 one time. 2 goes into 4 2 times. I'm just reducing, guys. You can do the reducing at the end if you want to. It's perfectly okay. 13 times 2 is going to be 26 square roots of 2, which is choice B. One of my students argued with me on this. It is B. They kept trying to tell me it was C, that that's not correct. That is the no, you found one side. I had to do the math several times. Okay, anything before we go on? Okay, are y'all still on the same page? Is it like on the same front? Okay, okay, here we go. This is not an easy problem, guys. There's a lot to it. It's not that it's hard math, but you have to know the formulas to be able to do this. What is the formula for the area of a regular polygon? 1/2 A, what's the next thing? Perimeter, that's P. Yeah, 1/2 AP. Okay, and what's the formula for the area of a rectangle? Length times width. Those are the two formulas you need. Not crazy, but you need to know those two to be able to do this problem. Okay, it's a hexagon, and every side is 6, so we're going to go down here and we're going to write 6 on every single one of these. We're going to put a dot in the center, and we are going to draw our triangle. Okay, from there, what else is it? Oh, we don't have anything else. Oh, we can't do this. Let's do the part where you should know what triangle it is. We've done it with hexagons enough to where you should know, but if you don't remember, here's the process. 360 divided by 6 sides is how much? 60, and then 60 divided by 2 is 30, so that makes this a 30, 60, 90 triangle. Because the apothem cuts this base in half, how long is each side going to be? 3. And that 3 is going to be what leg of that 30, 60, 90 triangle? The short. And we're going to go from the short to the long. So we have to multiply by the square root of 3. Now look at your answers, guys. Do you see your answers? Do they have any decimals in them? So keep it just 3 square roots of 3. 3 radical 3. This is kept in terms of the radical, so leave it just 3 square roots of 3. Okay, here we go. Let's find the perimeter. Perimeter is 6 sides times 6 each, which means the perimeter is going to be 36. And then your area formula is 1/2 times the apothem, which is 3 square roots of 3, times the perimeter, which is 36. 1/2 times 3 square roots of 3 times 36. Guys, y'all understand you're only multiplying on the calculator the 1/2, the 3, and the 36? So what's 1/2 times 3 times 36?
54.
So 54 square roots of 3. And so your answer choice is choice. Nope. What did we just find the area of? The whole thing. Have we subtracted anything yet? We have not done the subtraction between the two things. But do you see, I'm trying to make this point. I'm not being ugly, guys. I'm not trying to make you feel stupid. I'm not trying to do any of that. What I'm trying to do is show you what test creators do. They put things in here as detractors. You just did all that work and you're thinking, okay, I've got the area. There it is, 54 square roots of 3, and my answer is in the thing. But that's the area for the entire shape. What we need to do is only get the shaded areas that are out on the side, which means we need to subtract the rectangle in the middle. Now, that's not very hard because the area formula for a rectangle is area equals length. How long is it across the bottom? 6. Times the width, or the height in this case. So that's going to go this way. We don't have it yet, but it's not hard to find. Watch. If this is 3 square roots of 3, and we drew it up here, it would also be 3 square roots of 3. And if we take all that together, what's 3 plus 3, guys? So it'd be 6 square roots of 3. So the length is 6, the width is 6 square roots of 3. What is that when you multiply it? Okay, now look at your answer choices again. Am I making my point clear enough? So, do you see the 36 square roots of 3? But is that your answer? What did we just find the area of? The rectangle. What do we need to do with those two numbers? Take this and subtract this from it. 54 square roots of 3 minus 36 square roots of 3, which is 18 square roots of 3. Now guys, that's a problem that makes the difference between like a 3 and a 4, or a 4 and a 5. It could also make the difference in the not passing and passing for some of y'all, because you may get that when a lot of people don't. Even if you, try, guys. I'm telling you, don't just skip problems. If you have a shot of getting it at all, please put an answer down no matter what. Even if you have to guess, please try them. Okay, guys, here. Again, your grade is based on you compared to other people, not just you. Okay, let's go down here. This is a very similar concept, easier formulas. Let's go through and do this. First, what shape is this shape down here on the bottom? Trapezoid. That formula is 1/2 times the height. What is the height of this trapezoid? Oh wait, 7 for the trapezoid, times 7, times base 1 plus base 2. Well guys, we don't have a number here, but we really can find it. Look, this height is 3, so the radius of this circle is going to be 3. If I drop the radius to this side, it's going to be 3. If I drop the radius to this side, it's also going to be 3, which means this distance all the way across is going to be 6. So base 1 is going to be 6, and base 2 is already on there at 9. Anybody have any questions about that formula before we start? Okay, type that, give me an answer. Remember, you got to do the adding first, because otherwise, if you don't do the parentheses, it's going to mess it up. So do the adding first, then multiply. Add first, then multiply. Do what's in the parentheses first, then multiply. Okay, what's that give you? I don't have it, guys. I gotta have yours. 52.5? Perfect. Here we go. So that is this area down here. This is all of this shaded region. Okay, so we're going to have to add something to that. So we're going to take that 52.5 and we're going to have to add all of this to it, but we got to find that area first. Okay? Guys, what shape is this a half of? It's half of a circle. And so is this. It's a half of a circle. So we're going to have to take one circle, take half of it, and then subtract another half of a circle from it. So your formula would look like this. First of all, what's the formula for the area of a circle? Pi r squared. So 1/2 pi r squared minus 1/2 pi r squared. Okay. Oh, what are our answers in? Are they in terms of pi or like, no, they're not. So we'll use 3.14. So it's going to be 1/2 times 3.14. What is the radius of the big one? 3 squared minus 1/2 times 3.14 times what is the radius of the smaller circle? 1.5 squared. Okay, listen, I'm going to try to let y'all type it by yourselves. Try typing it by yourself straight across. 1/2 times 3.14 times 3 squared minus 1/2 times 3.14 times 1.5 squared. And let's see if y'all can get the same answer. We got to be able to do those calculators in just a few days. We got like, I think we take our test a week from Tuesday. A week from Tuesday. Still haven't told me which day's calculator day. I'll let you know as soon as I find out. I'm trying. Okay, guys. When you get it, tell me. Anybody got an answer? Almost. 10.59. Did y'all get about that too? It's an approximation, so what's 10.59 when you round it off? 10.6, we'll go with that. It doesn't have to be exact because the answers are rounded to the nearest whole number, so that'll be efficient. That's good. Okay. So add those two together now, because that's the top area plus the bottom area, which is going to be like 60, it's actually 63 point something, isn't it? Point what? 1? Okay. And that, guys, do y'all see, is about 63 square feet. And they said approximate. They didn't tell you what to round to, but y'all can see they're all whole numbers so down here. So 63.1 is closest to 63. Do you see how they tested like several different things in this though? They did the formula for a circle, they did the formula for a trapezoid, they did the idea of taking and subtracting that one away, they took the idea of putting two together for a composite figure. That's a lot of information in one problem, and since they can only give you so many problems a day, that's what they're going to do, is test a lot of skills with each problem. Okay, let's keep going, guys. So 7 I told you to do on your own. 8 let's look at real quick. So 8, if we're going to make this a parallelogram, let's take a look at what they've got. The diagonals of PQR are congruent. The diagonals are only congruent in a parallelogram if it's a rectangle, a square. So that's not every parallelogram, so that would not work. That's out. Okay, they are congruent in like an isosceles trapezoid and other shapes, so that doesn't work. The diagonals are perpendicular. That happens in a square and a rhombus. Those are both considered parallelograms, but there are other parallelograms that don't, so that does not work. The diagonals bisect opposite angles. Guys, look up here. That's true if it's a square. That's true if it's a rhombus, but that's not true in this. Look, is this angle the same as this angle? No. So that one's out. The diagonals, look at the picture. Remember how I told you sometimes they give you information? Look at the picture. Do you see the picture has the diagonals marked as being bisected? You see the mark? It says this one is congruent to this one, and then it says this one is congruent to this one. So it's choice D. They gave you the picture and like gave you the clue, but if you don't pay attention to those kind of little things, you might miss that. Okay, guys, is this now on your back? On the back side? Let's go to the back side, guys. Okay, for problem number 9, we are putting these in order. I'm going to have to take it down back to the size, and then I'll put it back up again when we get to the next one. But I can't see the whole problem without doing that. I can't even see it on 100 almost. So it says Richie was given the following statements and corresponding reasons, and he has to put them in order to complete the proof. So here's the picture. It's a rhombus. In a rhombus, we know that, first of all the sides are the same. Let's mark that. Okay. And it says, which is the correct order for these statements and reasons? So guys, when you start a proof, what's usually the first thing you do? Given. Is there a given statement somewhere in this problem? Number 3. And look at these. Look down here. Here's another clue. Do you see how 3 is the first one in 3 different separate answers? Chances are that's probably going to be the one. Let's look. Yes, 3 is your given thing. So I can cancel out C immediately. Because you can't talk about any other thing until you tell me that that is a rhombus. That was given to you. The next thing, we've got a 4, and a 1. So we're going to compare 4 and 1. What does 4 say and what's 1 say? 1 says this is a right angle, and 4 says they're perpendicular. Well, you can't say it's a right angle until you know the lines are perpendicular, so which one has to come first? Number what? Wait. Do you know they're 90 first, or do you know they're perpendicular first? Perpendicular. You have to know they're perpendicular in order to know that it's a right angle. So that's going to be number 4 comes next, so we can eliminate that one. And that's going to be our next one. But guys, it's pretty easy now. Now that we've said they're perpendicular, what kind of angle do we know it is? So which one is that? Number 1 or number 2? Number 1 is that angle. Because they're perpendicular, this angle right here, the SVR right here, is going to be perpendicular. If these lines are perpendicular, so this angle is going to be 90. Which is going to be choice A. Now, if I was taking this test for real, then I would check the last ones and see if 6, 2, and 5 works, because this test decides a lot. But we've eliminated, we've gotten down to that. Alright? Okay, guys, let's take it back up so we can see it. I think 10 was another one that I told you to do, but I'm going to draw the picture with you. I'm not going to do the problem, guys, because we did a problem almost identical to this on number 5. It's not as complicated at all, but it's another hexagon with the same measurements and a lot of stuff the same. So I'm going to draw a picture for you. I'm going to draw a circle best I can. Ooh, got a dent in it. Just up. You get the idea. Okay, it says you have a regular hexagon inscribed within a circle. So here's the circle, and then you draw a hexagon in the inside of it. The easiest way to do it is draw the points and try to connect them, because otherwise you don't even get close to the shape that you're trying to do. It's not easy to draw this. That one was bad. Okay. Good luck, it's not easy. Okay, from there, it says it has a radius of 6. So if I take this and I draw a radius to that outside edge, that's going to be 6. That means this one is also going to be 6. And guys, it's a hexagon. We just did this. What kind of triangle is it going to be if it is a hexagon? 30, 60, 90. And I can't make it small enough. Let me see if I can take it up to 200 to work on that one problem. So that's going to be a 30, 60, 90 triangle. And that 30, 60, 90 triangle has a hypotenuse of 6. To go from the hypotenuse to the short leg, I'm going to divide by what? 2, which would make it 3. And then to go from the short leg to the long leg, I'm going to multiply by what magic number? Radical 3. And it's going to make it 3 square roots of 3. Now guys, from there you should be able to find it. It's the exact same information off the last one. It's got a, you'll be there. You can do this. Okay, from there you've got this. Okay, let's keep going. That was just kind of bonus for helping get that started. Okay. Oh, I got to take it back down a little bit to be able to see this one. Okay, this is a geometric mean problem, guys. You can do the ones that float. You can do the ones with the A, or you can do the ones with the B. But let's look at what it asks us about. It asks us about trying to prove triangle CDA. That is this triangle that's over here on this side, similar to the triangle BCA, which is the whole thing. So if you want to do the one on the right side and prove it congruent, which floater are you going to use, the A or the B? Which one's connected to the triangle on the side we're trying to do? Guys, y'all see it or not? Okay, I'm going to do this 2 different ways because I can tell this is not connecting. B is going to be here. It's the floater. It's going to repeat on our proportion. Okay? That repeats on our proportion here and here. that B is going to be connected to this piece right here, which is C minus M, and the whole thing right here, which is C. Alright. Now, which one of those choices is that? D. D. I'm showing that another way because I don't feel like y'all got that down. So we're going to show you a different way to do this. And last period, somebody did this much better when I did this. Okay, I'm going to draw the picture. This part of it. I'm just drawing little pictures of it, guys. This is going to be B. This is going to be C minus M. I'm going to draw the big triangle. Now I'm going to draw it the way they draw it, just so you can see it like it's up here. Okay, and this is going to be B right here, and this is going to be C all the way across the bottom. Okay, guys. On this picture right here, the C minus M right here, I'm going to change to blue so you can see it. C minus M is the short leg, the long leg, or the hypotenuse? Long leg. I'm going to put an L beside it. The B right here is the what? Hypotenuse. Okay? Now I'm going to look at this triangle. On this triangle, the B is what? B is the long leg. It's got to be a leg because it's touching the right angle and it's the long one. And C is the what? Hypotenuse. I'm going to set up my proportion based on that information. I'm going to put the legs on top and the hypotenuse on the bottom. So my legs are going to be C minus M over the hypotenuse B. And on this side, it's going to be the leg over the hypotenuse, so it's going to be B over C. If that works better for you, you can do it that way too. Whatever works, guys. Okay, let's keep going. Trying to get as many in as I can. Yeah, what you got? Okay. Trying to get as many in as I can, guys. Okay, didn't I tell you to do 12? Yeah, y'all know you can just mark. All you do is mark and then decide whether it's angle, side, angle, side, angle, side, whatever it is. If it fits one of those, it works. If it's like Kershing, it doesn't work. Can't Kersh, can't do angle, angle, angle. That doesn't work. Okay. Okay, let's go to this one. Okay, for this 14, this is the stuff we just took a test on. These two, we're going to do 13 and 14 right now. Actually, let's do 15 first. Guys, if you're starting at the one in the middle and you end on the one on the outside for the primes, what are you doing to that original shape? Are you dilating it, rotating it, reflecting it, or translating it? It's a dilation. Makes a big. Anything that changes size is going to be dilation, guys. So that's going to be choice A. That's number 15. Now we got to do the same thing over here, but we're doing different movements. So when we look at this, if we took this and we did a 90-degree rotation, so we took it, laid it down, and then we slid it, could we get it to slide on top of number 2? Took this, laid it down. If we laid it down, it would go this way. And then we slid it over here. Could we slide it to look like that? Yeah, that's a possibility. Let's mark that. Let's do it again for the next one. For the next one, it says horizontal slide. So that would just mean that we're taking it and sliding it this way. It's going up and down like that one. And then we are doing that changes the size. Are we changing the size at all? So that one's out immediately. That one changes the size. That's not it. Okay, let's see on the next one. A reflection across the horizontal. So here's the horizontal axis. If we reflect it across it, it would be right here. And then what does it say? A slide. If I just slide this over, is it going to be facing the right direction? No, so that one's out. I hope it's A then. What's the last one? Reflecting across the vertical axis. So let's draw a vertical axis. Let's say it's right here. Let's reflect across that. That would make it land. And then 180-degree rotation would just rotate it down and put it like this. Does that, or actually the other way? It would actually take it and put it like that. So is that going to end up on top of it? No. So our choice is A. Those are quick. Okay. So let's see if we can get these at least set up, if not ready to go. So guys, they give you this whole paragraph to tell you that the lines are parallel. This doesn't even matter. Read it, yes, read it to make sure, but that they give you the picture. They tell you the lines are parallel. If the lines are parallel, it cuts off proportional parts. So if this piece is 6 right here and the whole thing is 10, how long is this piece down here? 4. And then guys, I can set up proportions in order to do that. It's already a proportion. Y'all see that the fractions are already here. Like, you extend the line out, put the equal sign in the middle, there's your proportion. It's 6 over 4 equals 9 over x. Cross multiply that, that'd be 6x equals 36. Divide both sides by 6, and x equals 6. And they're only asking for x, so you're done. We're going to get all of them done except those ones I assigned you. That's awesome. Okay, so you only have 4 left. So here we go, guys. Last one. What is the measure of angle A? So you got to look at your similarity statement. Your similarity statement right here says angle A matches up with angle F. So this angle is the same as this one. Angle B is going to be the same as angle E. So if B is 36, then E is 36. Angle C matches up with angle D. So if D is 20, then C is also got to be 20. Guys, every triangle adds up to 180. So we would add the 20 and the 36. That'd give us 56. And 180 minus that 56 is going to be, what is it? 124. Oh, I put 4 there. I must have already thought through the subtraction in my head. So it's going to be 124, which is C. Okay. Does anybody have a question about any of the 4 that I gave you before you leave? Just anything specific that you want to ask me, a formula, anything on those 4 problems that you want to ask me about before you leave? Did you draw a picture for number 2? Number 2 is going to be set. If you draw the picture, you'll be able to see what to set up. Yeah.
Use trig for number 10.
Huh?
Use trig for number 10.
Number 10. Number 10. Number 10. Trying to find the area of. No, you have to do that 1/2 times the apothem times the perimeter.
Sure.
Yep.
Can you give the formula for number 10?
Yeah, 1/2 AP. 1/2 A, lowercase a, capital P. So you'll find perimeter first and then plug it in that formula. Yep. Anybody else? Anything else? Look and see. Draw the picture for number 1 and see if you can set up what it is. Well, maybe we'll tell each other what it is if you'll set it up. Draw the picture and see if you can set it up. And I'll tell you. For number 2, or sorry, what was it, number 2?
Yeah.
Sorry, number 2. Try doing that real quick. Try to draw the picture for number 2 and see if you see what kind of problem it is. That way everybody will know going into the weekend. That way it'll be easy. Draw the 2 windows, I'm telling you guys. Draw, draw, draw. What would you set up if you've got that on there?
Proportions.
2 fractions, which is a proportion. That is good. Good teamwork, guys.
Yeah.
Good teamwork. It is 2 fractions, 2 ratios, which makes a proportion, which is correct. And you'd cross multiply to solve it. Okay, guys. We've got 4 problems to do this weekend. Get them done. You can do 4 problems.
I got C.
Okay.
Is that wrong?
I don't know. Let's look. But we did it with special right triangles and got you there. You don't need to do that. You don't like special right triangles? You can do it actually. What number? Wait, what number is it? Oh, what is it? I keep turning it upside down. Yeah, see, you got it. Yeah, you can always use trig when you got special right triangles, as long as you have the side that's missing that you like it. As long as the numbers are in ways that you can do trig. Yes. Okay, guys. So you've got 4 problems to show me on Monday. We've got the second half of this worksheet on Monday. Then we've got FSA on Tuesday and Wednesday of next week. Yay. More testing. It's like the season O testing now. That's all we do. Okay, so I can put this up for y'all. This was assignment number 29. Go. Finish these 4 problems. We'll use this one. And this will be our last day like this. Monday will be the last day we do one together. The rest of them are kind of different. Some of them there's a recording for one. It's just because it's what it is. And then there's the vocab for one day, you know, I told you that other formula sheet that's really important. We got that one day, so this Monday's the last day that we're doing it kind of the way we've been doing it the last couple days. And that'll be, what's Monday, 5-2? 5-2. Okay. Oh, yeah, thank you for getting that done early, because I've got two that asked me to do them yesterday for the Rex, and so now I have them, but they're not here because of the pep rally. So, I'm trying to get them to her, but she's not here, so thank you for getting yours done. And it was easier to do it on the computer. That was much easier. When are, tryouts? Monday? Ooh, good luck. Good luck. Hope it goes well. I know you'll do amazing. Okay, I'm not gonna close that. Bye guys, have a good one. Have a good weekend. I will see you back here. Do those 4 problems, please. There's only 4. Come on, get them done. 4 problems to do. Bye guys. Bye guys, have a good weekend. I'm gonna go make sure Miss Garcia's class gets in the right place. Hello. Make sure you turn in, no, that's not y'all. Turn it in. Write down this and pick up those stuff.
Watch out, Mohammed, bro. Get your nips off of me.
Last night was fun, Baker.
What? Sure was.
You don't have a pencil? God, no.
Shit, gotta make that your shorter.
Around the world, around the world. What, William, get a charger? Not a charger. Pencil?
A charger. Get a charger, brother. Listen, get a charger.
Shut up.
Brooklyn, get a charger. Brooklyn, get
Such a boozer kayo dun sa number to.
Wait.
Sorry, I like to clear people out a little bit.
And a big.
Arabic.
I thought you were Mexican.
No.
Oh, wow.
That's racist.
Oh, wow.
Assuming my race.
Wait, so you're not?
Clearly he's not Mexican.
You just want to do hot pot, soft pot.
Bacon. Who what
We
Ibn
better be
Shalmuta?
touching this part. We're not even
Who what Ibn Shalmuta?
Who what?
Ibn
Ibn
Shalmuta.
Shalmuta.
Yeah, you
Ibn
know.
Shalmuta.
No, you just said that. You just said son of a whore. You called him a whore.
Ibn Shalmuta.
Ibn
Shopped in and come back.
Ibn Shalmuta.
Oh, I didn't want.
You finished?
No, somebody say come back.
Even come back.
How does he know? Oh, I did not know that. Even
You should
Shalmuta.
say Immak Shalmuta, which is the longer word.
I sure did.
Or Immak Ibn Shalmuta, which is the longer word.
Okay. That's racist.
Yeah, we're well known. Existing.
Yeah.
Post for the camera that doesn't fit. In so many dynamic groups.
It's a bright red. Looks like
I don't know.
but it's so gross. It's correct.
Is it us?
Probably.
Boy.
Hers is not.
Write that down.
Can you see the baker say Kosa?
Cosa?
Kosa.
Cosa. I like being
Kosa. That means
Cosa.
Kosa.
Cosa.
Kosa.
Costu.
Huh?
Yeah.
Real word.
Such as loser.
What? No. We don't turn it in.
Yeah, we do. You know she's gonna make us.
She's not. I already asked her to cut. Why did everyone turn in their homework? It doesn't
Because
say.
I was expecting you to take them.
It doesn't say to turn in your homework.
Yeah, well, didn't it last time either?
Yeah. Since.
Oh gosh. Oh my god.
Ken, say Kosa.
No.
Kosa ya Ibn Shalmuta.
No.
Say it. Say it to her. Say it to her right there. Say Kosa ya Ibn Shalmuta.
Also get image from this.
What does that mean? Your mom
Does it mean?
What does it mean?
Guys, have a seat. Pick up your stuff and have a seat. Whoever's paid for this is, go get it. Go get it. Doesn't have an arrow, doesn't tell you to turn it in. No, you're not. It only does it if it says that too. Thank you though for doing what you probably done. We do it sometimes, we don't do it others. We don't do it every time. Somebody left it, thank you. Appreciate that. Okay guys, if you have not done so already, you're going to record this information from right here onto your assignment sheets. Please write that down and then write down the date for the warm-up. Guys, I want to move quickly today because I want to try to, it's Friday. I would like to try to do as many problems as I can on your worksheet with you. Okay, today and Monday are the last days we're going to do together. Because after that we've got vocab to finish up. We've got different types of worksheets. We've got that new set of notes that I told you reviews the stuff you're supposed to have from middle school. There's going to be a little bit different pattern after we do today and Monday. So please get that written down so that we can move on pretty quickly. Hold on one second. Let me get attendance and then I'll get you. Guys, hush. It's not that hard a concept. Keith is just in the restroom. Everybody. Gabby's here. I mean, not Gabby. Reagan's here, Gabby's out. So 1, 2, 3. Yes, ma'am. Okay, it's in the file. Yep, and then it's posted online. Huh? It's a half slip, so it's down in it. So go look, go grab it real quick. It's 4-16. Go dig in that file. If you can't find it, I'll help you find it. Go grab that. Okay guys, so our warm up today is starting with an evaluating problem. I'm going to do this like you don't have a calculator because They are going to give you problems on calculator day. They are going to give you problems on non-calculator day. This would be a problem. They would expect you to be able to do basic arithmetic without a calculator. This is order of operations. You see it in there? Nope. There you go, you're welcome. But thank you for asking. I ran out of things, like more things. Okay guys, here we go. So when we're looking at this problem, the first thing you're going to do is rewrite it with the numbers plugged in where the variables would go. It'd be 4 times 3 squared plus 3 times 5 all over 5 times 3 squared. Guys, out of order of operations, what has to be done first out of everything in this problem? The exponents, thank you. So we would rewrite it as 4 times 9 plus 3 times 5 all over 5 times 9. You take care of the two exponents before you do anything else. Now what comes next on order of operations? Multiplication. Very quickly, thank you. So 4 times 9 is going to put us at 36. 3 times 5 is going to put us at 15. Guys, I'm about to stop and be done, because if you're not going to be with us, then we're not going to do this. You're writing down what I'm writing down. This is your biggest part of your folder check for our last one, and you're not sitting there in space. Catch up with us, please, before we have to stop. And then on the bottom, we're going to have 5 times 9, which is 45. We're going to add the numbers on top. 36 and 15, guys, 6 and 5 is 11. Carry your 1 over. 3 and 1 would be 4, and 4 plus 1 would be 5. However you need to think through that process. I also do it like this. I say 30 plus 10 would be 40, plus 11 would be 51. However your mind thinks of it. And then on the bottom it's 45. Why is this not your answer? It's not reduced. So top and bottom can both divide. Do y'all know what goes into them? 3. That is correct. Nicely done. Hadn't had anybody say it right away today. That's good. So 3 goes into the top, 3 goes into the bottom. 3 into the bottom is a little easier. Most people see that that one is 15. If you have to do the multiplication over here and do figure out what it is, 17 times 3, that's 21. So the 1 goes down there, carry your 2, that's 51. Do whatever you got to do, because you're going to have a non-calculator. You have half of this test does not give you a calculator. So that reduces down to 17 over 15, which is choice A. Your answer goes up here. Be careful. I almost wrote it on this one the last class. Someone stopped me, but yes, be careful. It's easy because it's at the top, not the bottom. Okay, guys. The other problem is going to be what we call a literal equation. A literal equation means you're solving for one variable when there are other variables in the problem. In this case, we're solving for x, which means we need to get to the top of the fraction. In order to do that, we need to get rid of the denominator. How do you get rid of the 3t on the bottom? Multiply. There you go. Multiply by 3t is exactly correct. You multiply both sides by 3t, that cancels out. Oops, sorry, that looks like I canceled out the x. Let's do it this way. That's going to make it mx plus px is equal to 6t. I want to get both the x's out. They're a common factor, so I'm going to factor them out. If I factor the x out and put it out in front and divide both of these by x, what would be left to go inside the parentheses? M plus p equals 6t. Divide both sides by m plus p. That cancels out. That leaves me x equals 6t over m plus p. Now, there's not one that's exactly like that over there. However, can you write an equation backwards and it still be the same thing? Yes, symmetric property of equality says you can switch the sides, which means which choice would it be? A. There you go. That's your warm-up for today. When you are done, put it in your warm-up section and then take out last night's assignments. Take out last night's assignments. Oh, pass it around. I thought that. I pulled, that's funny, because I hole punched all the rest of them, and I forgot to do this little part of it. I pulled, like the ones that we do for the rest of the year. I think we've got 2 of them left, and I hole punched those already, but I didn't do this one. Okay. Guys, you should have that worksheet that we did yesterday out. I'm going to call out the answers. You're going to need to go through and check and correct these. See if there's anything you need to ask me about any of these problems. We had very few we didn't do, guys. But I'm going to call out the answers to the whole thing just so you can get it. Everybody needs to get that worksheet out. Got it out? The one from yesterday? Not today's. The one from yesterday needs to be out on your desk. Okay, this is going to be problem numbers, I think it starts with 16. Okay, I just want to make sure I was on the right one. They got it. AJ, if you'll just put it on the thing behind you, that'd be great. Thank you, sir. A little sill. Thank you. I appreciate that. Okay, guys, here we go. Problem number 16 is C. Problem number 17 is A. Problem number 18 is B. Problem number 19 is D as in dog. Number 20 is B. 21 is B. 22 is B. They like B. 23 is B. 24 is D as in dog. 25 is A. 26 is A. 27 is B as in boy. 28 is A. 29 is B as in boy. 30 is C. 31 is D as in dog. 32 is A. And 33 is C. So, guys, you have the corrected answers. If you want to ask me questions, anything pertaining to that, you can, but it'll do it one-on-one, okay? Because I want to use the time that we have today to get into this new worksheet. Again, we're going into the weekend. This worksheet contains some things that you are supposed to have from middle school and some things you don't ever get to that we need to talk about how to handle, okay? So there's a lot on this that I want to make sure we get to today. Does anybody have any questions before we start on the new one? Now this new one that we're doing today, you're just going to turn in when we walk in on Monday. We'll do our last regular, like doing it together on Monday, and then things get a little different because y'all start FSA testing on Tuesday. And so we're going to have to handle things a little bit differently after that because even like Thursday and Friday, things are going to be a little different. All right, anybody have any questions? Okay, everybody should be looking at their new worksheet, guys. Let me close this out.